So, in the previous class, we stopped at composite numbers, isn't it? We started and we will complete now. So, composite numbers are what? What is the simple definition of composite numbers? A number which can be divisible by more than 2 factors. Composite numbers. So, composite number definition is that, definition is what? A number which is divisible by more than 2 factors. That is a simple definition, right? More than 2 factors. Right. Next you can see are non-prime numbers, or you can say, so non-prime, in a simple language you can say non-prime numbers. There is no such word in mathematics, non-prime numbers. This word non-prime numbers. Non-prime number, there is no such word in English language. Anyway, for our understanding. So, and if you start writing numbers, a number may be which is a prime or a composite. Which is a prime or a composite. Either one, this or that. Except in the case of 1. Like, so if you see the numbers, you can see if you write numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and etc. Okay, right. And see, this is a prime number, this is a composite number, sorry, this is a prime number. No? This is a composite number, prime number, composite, prime number, composite, and this is a composite number, composite, prime number, so composite, like that, except in the case of 1, except in the case of 1. So, 1 is neither a prime number nor a composite number. 1 is neither a prime number nor composite number. Except 1, every number which is either a prime number or a composite number. So, this is the properties of numbers, right. Next, composite number is equal, LHS equal to RHS, left hand side value is equal to right hand side, is equal to prime factorization. This is this another property of this, put in rectangular box. Okay, composite number is equal to prime factorization, not prime numbers. It's not a product of prime. Sometimes you can see my guesswork. A composite number is option A, option B, option C, option D. If you put like, so far it is not there. There may be a possibility, because these are the properties of numbers. Anything is possible. Number is product of prime numbers prime factorization only A, like none of the above, See, product of prime numbers and prime factorization. So, we have to choose either A or B. So, prime factorization is the correct option. If you say product of prime, again this is product only, but product of prime numbers means what happens, we take only say for example let us take 20. 20 is the product of 2 into 2 into 5, right. So, product prime numbers means only we take only 2 into 5, 10, not. Factorization means 2 square into 5 to the power of 1, like that. So, 4 into 5 is 20, that is why prime factorization is like that, not product of prime numbers or prime factors. Also you can say it is not correct. Prime factorization, factorization is the equivalent value of a certain number. So, that is a thing, right. Let us see some examples of it. Now, see, composite numbers, I will write is a composite number, okay, and prime factorization, prime factors, prime factors, and write for 30 now. Write for 30. Now you write. Put a table. If you make a table, you will remember forever, that is. And how to find the prime factorization? LCM. LCM you have to take. 30 LCM. Always you have to do the LCM with the least prime numbers. Least prime numbers. So, start with even number. Since this is an even number, you can start with 2. So, 2, 15. Then odd number happen 3, 3, 5. It means 2 into 3 into 5. The 5 factorization is 2 into 3 into 5. What are the prime factors? 2, 3, 5. There are 3 prime factors. Somehow they create the question like that. Only thing is we need to understand the terminology of that thing. Okay. Yes. Next you can take for 40. 40. You write for 40. What is for 40? 2 into 2 into 2, 8 to 5. Okay. So, 2 cube into 5. Now, what are the prime factors here? 2 and 5. It's like that. There are only 2 prime factors. Right, that is a thing. And say like 250. 250 is a composite number. It is a composite number. $250. What is the process of finding LCM? 2, 125. 5 is a multiples of 5. When the last digit is 5, it is also multiples of 5. When the last digit is 5, it is a multiples of 5. It's a prime number, 5 is also. So, 5, no. 5 2s are 10, right, okay, 5 5s are, yes. Now, we can see 5 cube or 2 into 5 cube, 2 into 5 cube, or here 2 and we take 5, it's like that. Yes, next 820. Do it for 820. So like that. 820 and 2410 225 54 like finish. So 2 square into 5 to the power of 1 into 41 to the power of 1. And 41 is a prime number. If you don't learn prime numbers till 100, then you find difficult whether it's a 41 is a prime or composite number. There's problems will crop up. So the reason I have said that is you must be knowing the prime numbers till 100 like that. Otherwise it takes time. You got the answer, but you find difficult to choose the right option. Right. So now we can say what are the prime factors here? 2, 5 and 41 are the prime factors here. Just like that. The last one, let us see, that is 1020. 1020. Now you can see 1020. 2 5s are 10, 2 1s are 0. Okay. Again is an even number. 2 2s are 4, 2 5s, 5 you can say 5, 5 5s are 5 1s and 3 17s, right. The 5 plus 1 is 6, it's a multiples of 3. 5 plus 1 is 3.
So first 3 number.
Huh?
255 is also divisible by 3.
Yes. You can do it also. It will be the same only.
The small
Yes. Fine. Like 5, 10. Say 2 or 2, 55. Even you can make it 2 plus 5, 7. 7 plus 5, 12. Multiples of 3. 3. 25, 3. Now it is a multiples of 5. Yes, 5, 17. You will get same. Either way, no problem. So this is also correct and this is also correct. What are the prime factors? You can see 2 square. 2 square into 3 into 5 into 17. And see what are the prime factors? 2, 3, 5 and 17. So this is the LHS equal to RHS. But again, if you write for any like a prime number, this is the prime number, there is no factorization. Prime numbers do not have factor because it's a product of 1 and 17. 17 itself is a factor. It's like that. Right. Yes. Now composite number part is over now. Yes. So next is what? What is the next item on the list? Factors. Okay. Factors. So right, again we learned already, we discussed little about factor. Now we will come with very officially fine. And definition is what? Factors. Factor. So definition. Definition of a factor. Definition of factor. A number which is divisible by a number which is divisible. No, it's not correct.
A number that can divide.
Yes. Right. So definition. A number which divides. No, this is not also correct. A divisor a divisor which divides the number completely or evenly, both are same meaning. Completely, leaving remainder is 0. Still, that's the thing. That's known as a factor. So you can say a divisor, leaving remainder 0, like that. So a certain number has to be divisible by a certain divisor completely, in other words. And see that, let us see some examples of this. Let us say like 13. 13 can be divisible by itself. The remainder will be 0. 1. Remainder will be 13 is also a factor. 1 is also a factor. It's like that. Okay. Right. If you take 13, if it is try with 2, divisor is 2, you will have the remainder. 2, 6, 12, 1. So there is a remainder. So 2 is not a factor of. And 29, if we try with the 3, 3 is 24, this is the 5, remainder is 5. Again 3 ones you can also try with the 2, that is. So remainder, so 3 is not a factor, it's like that. Like the factors may be anything, even if you take 29 by again 30 also you can take, 30 is a divisor, but it is not sufficient. Again we put one decimal and we take 0 like that. So it's not that is only a very simple definition. A factor, a divisor which divides the number completely, leaving remainder 0 is known as a factor. But sir, that's a definition which was given in even NCERT 6th standard book. Of course, we forget that. That is a different issue. Right. That's called factor. Right. Now we can see, and here also you can see that like perfect number. Perfect number. I think last year paper it was there. So how they cover it? But the same question they did not use that perfect number because they don't apply the mathematical terms or formulas. They don't apply, but they take the concept of it. Perfect. What is a perfect number? There is two types of number: perfect number and regular number. Okay, perfect number. See, is what here the formula is what if you see the definition. Definition you can take sum of factors divisible by 2 is equal to a number, is known as a perfect number. Say for example, that is so again is possible for only composite numbers. Factors means only for composite numbers. Okay, let us take let us not take 4. Let us take 4 is a number. What are the factors for 4 by itself? 1, 2. Okay, right. What are the sum of the factors? 4 plus 1 plus 2 by 2. See, 5, 7 by 2. So this is 3.5. So this is not the perfect number. This is not the perfect number. Right. The last year paper they asked in a different fashion, but concept is same. This is the concept. Because even I was a little confused also. So what happens, that is when I started writing book, I was searching for all these things. Even Wikipedia I referred also. There I got it. You don't see these things in any academic books also or any competitive exam books also. Competitive exam books, there are, they say CSAT book, but actually remaining to concerned to the CSAT, nothing can be seen in that. All aptitude only, general like that. 5 is a prime number again. Let us take 6. 6. What are the factors for 6? 1 by itself, okay, 2 and 3. These are the factors. Sum of the factors 1 plus 6 plus 2 plus 3 by 2. 7, 9, 12. 12 by 2 is a 6. See that. 6 is like that. It means it's a perfect number. 6 is a perfect number. 6 is a perfect number. Six is a perfect number. Then we have to check that multiples of 6 is possible or not. Multiples of 6. Let us take 12. We don't know. I am trying now. Okay. So, what are the factors for 12? 1 plus 12, 2 plus 2,
3, 4.
2 plus 6 you can take. Pair you can say 3. 3
4.
plus 4. I think that's enough. By 2. Right. You can take 13, 15, 21, 24, 28. 13, 15, 21, 21 plus 3, 24, 28. 28 by 2 is what? 14. So, it's not possible. No? So, I think this is not possible. Like that you have to take. Okay? Right. Some of the factors. Okay. And next you can see finding the factors. Now we can see that is 32. What are the factors for 32? See, factors for 32 is what? Factors 1 is an even number. 2, 3 is not, no, it's not problem. 4 we can take. 5, no, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, yes, 17, 18, 19, 20, 21, 22, 23, 24, again you will have the 32 only. How many factors are there? 1, 2, 3, 4, 5 and 6 factors are there. There are 6 factors. But so if the number goes up, we will find maximum number of factors. Instead you have to shortlist this structure. You can start with say that 1. So this is, you can write, if you start with 1 is a factor, 1 into 32. So 1 is also a factor, 32 is also a factor. See, 1 has come, 32 has come here. Next, if you start with even number, so 2 into 16. 16 is a factor, 2 is a factor. It's like that. Pair factors you have to see. 3 is not possible. 4 into 8, 32. And 5, 6, 7, 8. So 8 into 4. 8 into 4 same is there. You stop it here. So there are totally 6 factors. 6 factors. This is the thing. But you have to find in pairs. You have to find in pairs. If you keep writing, it takes a lot of time. Sometimes that becomes impossible. So if you do it in a pair work, you can finish it very fast way.
So if you go on dividing by small number.
Which small? Okay, LCM you can take. If you take LCM, you go wrong also, because you must be knowing the formula. Then it is you can do. For example, if you take the LCM 2, 16, isn't it? 2, 8, 2, 4 and 2, 2. Right. 2, 1. This is over. But how many factors are there? 3, 4, 5.
1, 2, 4, 8 like that.
32 is there. Now 1.
No sir. ಅಲ್ಲಿ ಫ್ಯಾಕ್ಟರ್ಸ್ 1 2 4 8 16 ಅಂತ ಸಿಗುತ್ತಲ್ಲ ಸರ್ ಈಸಿಯಾಗಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಕೌಂಟಿಂಗ್ ಅಂಡ್ ಗೋಯಿಂಗ್ ಅಪ್ ಟು 32.
Yes. No, I did not understand what you are trying to say.
ಸರ್ 32 ನ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡು ಹೋದಾಗ then we will get 16 80 8 4 are the multiples of 32 ಅಂತ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ಸರ್.
ಮಾಡ್ಬೋದು. If you are comfort command, then you can do it.
Every
Yes. So you can do it, that is right. Now if we do the LCM also is possible. There is a possibility. But if you do the LCM, what happens now? 2 to the power of 5. 2 to the power of 5. But 1 we don't take in LCM, isn't it? We learned like that. 2 to the power of 5. Anytime power you can, plus 1 should be added here, like that. So then 2 to the power of, it means 6 factors. If you go by LCM, that exponent's value should be added to the 1 extra for any number, such number.
That is only better, sir.
It's a small, very bigger numbers you cannot do like this also. We must be knowing both, but they do not go such big numbers. There are 2 such numbers are there. They come up with because that is a properties again. So 111 and 1001. These 2 questions were appeared in last year paper. So it's like that. That is a thing. And if we try, now you can see, for example, you can see for 1000. Then how do you do that?
How many factors, sir?
Factors. Finding number of factors. What are the number of factors?
One 5 25.
1, 5,
25. 125.
125,
250. 500.
500,
1000.
1000. These are the factors. So how many are there? 1, 2, 3, 4, 5, 6, 7 factors are there. Right? 7 factors are there. If you do with the LCM,
Sir, 250. 250 is a 500.
250 is the 2, this is
250 is a 500. Sir.
1000, no? 250, yes. 2, 125, 5, 25, 5, right. So 2 cube into 5 cube, correct? Right. What you have to do here, 2 exponent value is 3 plus 1 multiplied by 5, exponent value is 3 plus 1 you have to take. Okay, what is the value that is? Then 4 into 4, like 4 into 4, 16 factors are supposed to be there. 3, 4, 5, 6, 7. 2 cube, 5 cube, 4 to 4. The why this is like this?
10 11. 10 11.
There should be 16 factors. Right. So 500, 250, 125, 5, 25, 5, again is a 5. Okay, keep it aside. Now, if we take 1000 like this, 1 and 1000, 1 into 1000. If you take with the 2, 500. Again, if you leave 3 is not possible, 4 you can take. Last 2 digits are 2 zeros, 4 can be taken. 4 into 250. 5, yes, possible. 5 into 200. 200 has not come here. Okay. 6, 7, 8. 8 into 125. 9, 10 into 10 into 100.
10 times.
10 into 100. 11, 12. Is 12 possible? Like 12, no, 3 more is not possible. 14, 3, because 1000, if you take with the 12 means factors of 12 are 3 and 4. 3 and 4. That is co-prime numbers again. Right. 12 is not possible. 13, 14, 15, no. 16, 17, 18, 19, 20 is possible. 20 into 50. Like 25 is possible. 25 into 16. 26, 27, 22, 30, 31, 32, 30. 40 is possible, I think. 40 into 25. Like 50, 50 already it has come. Again reverse it will come. Not necessary. How many are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 into 2, there are 18 factors. Check it out whether it is correct or not. 5 into 200. 2, which one?
25, 2 times 200.
25, 25. This is 25.
Again also 25.
Here also, no? Yes. That's why I think this is 40 should be. This is not correct. 25 into 40, not 16. This is 40. See how many are there now? 16. 16. See, your method will not work here like that. That's what I am trying to say. Okay? Yes. If you go by your method, you are missing some factors. Right. Numbers are, this is we checked it, that's all. And now what we can say, if we take the LCM, 1 should be added to every exponent value and multiplied the exponents.
You will get the number of
Factors. Number of factors you will get. Why? Because now again it's a theorem based one. Why? Because theorem based one means, so 1 to the power of 0 is a 1 value. That factors are there. For any number if you take like that, 1 to the power of 0 is equal to 1. So we learnt LCM in school days is very simple. Whenever you get 1 is a remainder, we leave that. That's why it is like, again it's a theorem based. So it is the finding the number of factors. And if you go by like this, there is a possibility of missing number of factors. It's very difficult for anybody. Even for me is also, though I am teaching, it's very difficult like that. Right. Now we can see factors. For example, like 2, like 2 into 3 into 5, let us say. 2 into 3 into 5. What is the value of this? 2 to 6 is 30. 30 will get. Okay. These are the prime factors, factorization. You can call factorization, that is. But how many factors will happen? How many factors will happen?
Of 30.
For 30. How many factors will happen? What are the number of factors?
8.
Number of factors is 8. Number of factors is. How did you get this 8? LCM you did. Right. Even already this is a product of factors. It's a 8. It's like that. That was a question last year. that they are asked in a different fashion. They like that only, like passage type will come. That's why we must be knowing the origin concept. So, like that is the thing. Product is given, value is also given. What is the number of factors? It's like that. But we can prove it, how it is like that. Because that is what the logical thinking is required. And see now, you can say 2, 3, 5. What are the factors for this number? Isn't it? Product of this. Now we can see one factor is 2, a number which is divisible by 2. See, product of number, see, I tell you, always let us see. So now you have the number 2 into 3 into 5 is equals to 30. 30 is an even number. So 30 can be divisible by itself. Okay. Even 1 and 30 also can be taken, right? And you can take 2 and 15, product of factors is equivalent. 3 and 10, 4, 5, yes, 5 and 6, 6 and 5 again reversing it will go. So leave it, stop there. It means what are the factors are? There are 8 factors. There are 8 factors. Now, when the number is there, see, product of any number like 2 into 3 into 5 is always divisible by 2 because this is the product of 2, multiples of 2. Whatever the result you get here, that result is a multiples of 2. When it is multiplied by 2, that is divisible by 2. Okay. Again, I write very clearly. Okay. Two into 3 into 5. Because this, since is the multiples of 2, value, let us not know the value. That resultant number is a this is multiples of 2, definitely that is divisible by 2. Okay, already we have checked, 30 is there. Now, 2 into 3 into 5 by 3 also is possible. Because 3 is multiples of 3, this number, multiples of 3, so divisible by 3. And 2 into 3 into 5 by 5, yes, see that. Already how many factors you have? 3 factors, right? And now we can see 2 into 3 into 5. Now let us take 2 numbers. We have taken only one number. Now let us take like 2 into 3, yes. 2 into 3 is 6 and it is also either multiples of 6 this is. So divisible by 6. And 2 into 3 into 5 by 2 into 5 let us take. See that. And again you can take 2 into 3 into 5 by all 3 numbers you can take. 2 into 3 into 5. See. Again if you take 2 into 3 into 5 by 3 into 5 like that. So one number is over, 2 numbers is over, 3 numbers are over. Now we can see, and 2 into 3 into 5 by 1 also you should take more, that is. How many are there? So now we can see 3, 4, 5 like that. So like that you can take the numbers of factors like that. Okay. Yes. Like that. Now you can see 111 is equal to 3 into 37. You put in the box, rectangular box. Okay. This one, again this is a very fixed property. 1001 is equal to 7 into 11 into 13. You check this value. Use the calculation and tell me. Maybe I might have forgotten also. 1001 is the product of 7 into 11 into 13. Use calculation and check. Correct now? Right. Either 2 numbers fixed properties. Last year these two questions were asked. Okay, is like that. That is a thing. That are the factors. How to find the factors now? Now we can see. Now we can see number. Okay, factors are, that is sum of factors. The number of factors are over. Okay, sum of factors means what? You are putting like let us say 16. What are the factors for 16? What are the factors for 16? 1, 16, 2, 8, 4 and 4 means you take only 1 4. That's all. These are the factors. 5, 6, 7, 8 already has come. There are 5 factors. 3, 4, 5 factors are there. These are 5 factors are there. If you take LCM, what will happen? 2, 2 8s, 2 4s, 2 2s, 2 1s. 2 to the power of 4. 4, there is only one prime factor plus 1. It means 5 factors. It's a 5 factors. So that is the factor. Sum of the factors. What is the sum of the factors means what? Sum of the factors. This is the number of factors. Sum of factors means what? Like 1 plus 16 plus 2 plus 8 plus 4 is the sum of the factors. Just like that. That is enough, more than that. Okay. Yes, this is the fact. Whatever we know at least. Minimum. How many properties we can write for one? Uniqueness of numbers.
1 is a factor of each number.
1 is a factor of every number. Yes.
1 is neither prime nor composite.
A factor of every number. A factor of every number. Like that. Like that. It just. A factor, other properties of 1. What is that?
1 is neither prime nor composite.
That's what. Wonderful that is. Neither a prime nor neither a composite. Neither a prime nor a composite. Then what are other properties we can write? We have to think, create and tell, that is. Because already we did a good number of classes. A factor of every number, neither a prime nor composite. Next. If you write in the number system, except that every number belongs to prime or composite. So like that.
If 1 is the HCF
By itself. See, SCF of itself, like that. SCF is a common factor of itself. Itself is a highest common factor. Yes, next. Like 1 to the power of 0. 1 to the power of 0 is 1 like this. It's like that. What is the other thing like? What are the other things, other factors, what are other properties? What are other properties? One is What is the other properties of 1?
Smallest natural.
Smallest
Natural.
smallest natural number. Yes, wonderful. Smallest natural number. That's right. Smallest natural number. Yes, next. Any other properties possible for 1? So, you can see, for example, n is a natural number, raised to the power of 0 is always 1. Their questions are
1 to the power 0 is equal to
1 to the power of 0 only we have mentioned, but
Any number.
n,
any natural number.
n to the power of 0 is 1 where n is a natural number. This is where questions are asked. Already asked. N may be any value. N is a natural number. Any value. 1 to the power of 0, 2 to the power of 0, 3 to the power of 0, 4 to the power of 0, and so on. Always 1 is the value.
1 is the number which does not have two distinct factors.
Yes, you can say that.
1 is the only number.
There is only one factor. There is only one factor, like that. Every number will have two factors, two distinct
factors.
distinct.
So
Only
that
one distinct factor. That's all. Also, you can say except one, like that.
So because 1 has only one factor,
Ah.
that is why we call 1 as neither prime or composite.
Now, but adu prime, when you talk about prime or composite only, you say that is
So we call it as prime or composite because it has only one factor.
one factor.
Yes, sir. So it is
Ah.
not equal to
Yes. Okay. Right. Still it will keep it like that for our sake. Yes. So we need to cracking method we should come. Any other thing? For 1 factorial is equal to 1. 1 factorial is equals to 1. Even 0 factorial is equals to 1. Okay. So 1 factorial, 1 factorial is equals to 1. Even 0 factorial is equals to 1. See that. This is the uniqueness of 1. It's like that. Where questions are decided. This uniqueness of numbers will be the first chapter in my upcoming book. Nobody has covered. So like that. This will be the first chapter. It's like that. Because I want to sell the book. So marketing, that is, yes. So like that. 0 factorial is equal to 1 factor is also 1. 0 factor is also 1. So 1 is equal to 0 factorial. 1 is also equal to 1 factorial. 1 factorial everybody knows. Only thing is 0 factorial. So like that. Okay. Right. That's uniqueness of 1. Now uniqueness of 2. What's the uniqueness of 2?
Smallest prime.
Yeah. Like that smallest prime number.
and even prime number.
So even prime number, yes. Only even prime number. Only even prime number. Only even prime number. Smallest prime number. Only even prime number. Yes. Next. What are the other properties can be written for that? Uniqueness. That's called uniqueness of numbers.
A number ending with 0 or
Divides every even number.
Yes. So, as a divisor divides every even number. Yes, wonderful that is. Yes, any other thing like that? Any other thing that is. Right. Like product of 2 of the first two numbers, product of the first two numbers is equal to 2 only. The product of first two natural numbers, sorry. First two natural numbers, 1 into 2, 2. Okay, the product of first two natural numbers, like that. See, these are the uniqueness of numbers we have to do, that is. Some more things we need to learn in upcoming classes, that we can do. Now I am just touching the points, that is. So, as and when you recollect your memory, you get idea, you just write the items, that property. These are the properties of these two.
Last point I
Huh? Product of the first two natural numbers.
In natural number 1 and
Natural numbers, where do you start writing?
1 into
1, 2, 3. First two, 1 and 2. Product 1 into 2 is 2. Is like that. 2 itself is a product of first two natural numbers. This is the terminology which is used in the CSAT. It's not my terminology. Who am I, that is? Huh? I am nobody for anyone, that is. So that is a thing. That's why the people go wrong here. They don't even understand that. They think only time and work, time. That is very small questions you do. That's the fastest scoring area. So like that. So right, next. And out of 2, what happens here? I'll tell you that 2. For example, this is only possible for 2. Now 2 to the power of 1. What is the 2 to the power of 1? 2. 2 to the power of 2, 4. 2 to the power of 3, 8. 2 to the power of 4, 16. 2 to the power of 5, 32. 2 to the power of 6, 64. 2 to the power of 7, 128. 2 to the power of 8, 256, and so on. And so on, like that. See that 2, 4, 8, 2, 4, double. This property is only for 2. This property is only for 2, not for any other number. Every alternate year, one question is asked here. Every alternate year. What I have seen for the last 5-6 years papers. See that. It's just doubling the resultant number. This is only for 2. For example, if you take 3 to the power of 1, 3 square, 9, is not doubling the value. Take it over. If you take 4 to the power of 1, 4 square is 16. No, again. So 5 to the power of 1 and 5 to the power of 2, 25. Right. It means it will not come to any other number except in the case of 2. If you take 6 to the power of 1, 6 square, 36 is not doubling. If you take 7 to the power of 7 to the power of 2, 14, no. 8 to the power of 1, 8 to the power of 2, 64, again not match. 9 to the power of 9 square is 81, it goes on. Only possible for 2, nothing else. Again, the exclusive, this is called uniqueness of 2. This is uniqueness of 2. So that's why these are the areas questions are being designed, framed, asked. Like that. Now, what is next to 3? 3, okay, 3 we don't need that is a even then I put also for our practice sake. 3 is what? What you can say 3 for 3, uniqueness of 3. Huh?
Smallest odd
Ah,
prime.
smallest odd prime number. Smallest odd prime number. Smallest odd prime number. What are other things like that? Other properties 3.
If the sum of the digits
Ah.
number is multiple of 3,
Ah.
then it can be divided by 3.
Yes. Like
3 plus 6.
smallest like sum of digits.
Of a number
Sum of digits of a number.
is multiple of 3.
No, divisible by 3.
Or
Divisible by 3. Hence, number can be divisible. Hence, a number can be divisible by 3.
So that is why you should put multiple of 3, sir. So then the next line will be divisible by 3.
Okay, you can put one more like that. So, a number which multiples of 3 always divisible by 3, always divisible by 3, like that.
Uniqueness in the
Uniqueness, okay, we'll write it, that is.
you can write for every number.
Whatever, write, after that we can shortlist the things also. Let us see that, let us try to see that is. Okay, yes, that is a thing. This is the thing. Definitely it's not uniqueness, I understand that is. Uniqueness is something which is exclusive to the certain number, like that. Right, this is the 3. And uniqueness is, see, that is sum of first 2 natural numbers is equal to 3. Sum of first 2 natural numbers, sum of first 2 natural numbers, 1 plus 2 is equals to 3. Sum of first 2 natural numbers, 1 plus 2 is equals to 3. That is the thing. This property is exclusive for only this number, not for any other number. It's like that. So, fine. And next, what is other numbers you can take like that? 3, 4, 5, 6, 7, leave with that. Divisibility test, we will do that. And what is next? You can do for 9. Okay? We can do for 9. So, 9, there is a big thing like that. So, for 9, like that. For 9, you can see. You will see one single question from this. Consent to the 9. See, what is 9? Again, in the divisibility test, that is sum of the digits divisible by 3, number can be divisible by 3. That is there. Okay, general rule, that is like 3 and 9 both follows the same rule. But leaving that, what are other things like that? See, for example, if you take a 2-digit number, if you take any 2-digit number, take 2-digit number 54 and reversing the digits, subtracting from it, reversing the digit, subtracting from original number, the result is always divisible by, always divisible by 9. Always divisible by 9. This is the standard property. These are properties of 9. This is called uniqueness something. This is possible only for 2-digit numbers. Possible for 2-digit numbers. Because these are the areas you would see the questions. These are any number you can do like that. Right. Say for example, another examples let us take. 91 minus 19. 91 minus 19. What is the result? 91 minus 19 is 72. It is divisible by 9. So, it's like this. That is the thing. But when it comes to the CSAT, That equation I will tell now. It means, for example, result of is always divisible by 9, or you can say multiples. I spoke about the divisibility rule here. Let us say the straightforward. So, like 54 minus 45 is equals to, okay, straightforward like that. 9 into x. X may be 1, 2, 3, 4, 7, 8, anything. It means multiples of 9. It means divisible by 9. The sequence like that. 9 into x is like that. And see, even we will tell like how it is that like 54 plus 45. Shortcut is what? Right. Otherwise, we have to do like this: 54 minus 45. So 9. Yes, 9 into 1. Instead, you can see the difference between the digits. What is the difference between the two digits? 1. There is a 1, 9 is there. For example, you can say 91 minus 19. What is the difference between the digits? 8. So 9 into x, that is x equals to 8. X equals to 8. X value is 8. Like 63 minus 36, 9 into x, it means 9 into 3, 9 into 3, x value is 3. Very standard property for this. If you take any number, you can write another 5 such numbers like equation you write now. You can create 5 numbers and write like equation. That equation, writing equation is important. Not just understanding the concept, we must know how to make an equation. Yes, next one, another property of this. A number subtracting a number a 2-digit number, that is also a number which is either greater than or equivalent to 2-digit number, subtracting sum of its digits, resultant value is always divisible by 9, always divisible by 9, or multiples of 9, or divisible by 9, always divisible by 9, or you can also say the resultant value is multiples of 9, multiples of, also you can tell. When divisible by 9, it's multiples of 9.
Sir, why have you put subtracting sum
of its digits? Say for example, let us take first 2-digit number, 12, 2-digit number. No, first number is what? 10 minus sum of its digits, 1 plus 0. So it means 10 minus 1 is 9, is like the property. Say for example 11 minus 1 plus 1 is 9. So the property like that, 11 minus 2, no? So 10 minus 1, 11 minus 9, like that, and 12 minus 1 plus 2, 12 minus 3 is 9. Minus 1 plus 2, 12 minus 3 is 9. Is always divisible by 9, multiples of 9 anta. That we need to understand. When something is divisible by 9, it's a multiples of 9. Both are same. But property they mention like this, divisible by 9. I am telling you that it's multiples of 9. When something is to be divisible by 9, it's always multiples of 9. For any number if we take like that, it will come. We have taken 2-digit numbers. Even let us try for 3-digit numbers. Let us try for 3-digit numbers like 1, 2, 3 minus 1 plus 2 plus 3. It means what? So 123 minus 6. So 117. See that. This is always divisible by 9. Like. If sum of the digits 1 plus 1 plus 7, 2, say plus 9, yes, it's like that. So once you are connected to certain thing, there will be a same pattern everywhere like that. Now for example, you can take 1, 2, 3, 4, 5, let us take 5-digit numbers, minus 1 plus 2 plus 3 plus 4 plus 5. It means 1, 2, 3, 4, 5 minus 15 is equals to 1, 2, 3, 3, 0. See that. So it's always divisible by 9. 1 plus 2, 3, 6, 3, 9. Yes. Any such number can be taken here. Okay. N number of digits can be taken. It's a standard property. This is the multiples of 9. Yes. What is the next number? 11. So 11 you can take. Now for uniqueness of 11 you can take. Uniqueness.
Uniqueness of 5. Only prime number which is
You can take.
5.
Yes. 5 numbers, 5 also can be taken. How the 5 can be taken?
It's the only prime number which is a factor of 5.
See, if you take 5 like that, uniqueness of 5. What is uniqueness of 5?
It's the only prime number which is divisible by 5. Like every multiple of 5 is not a prime number.
Yes. So only 5. Only 5 is a prime. Only 5 is a prime. So this is okay. And multiples of 5 is not a prime.
It's always not a prime number.
Multiples of is not a prime, because for every prime number it will come like that only. Multiples of any prime number is not a prime number.
7 sevens are 49.
Howದು 7 sevens are 49 is not.
7.
That's all.
ಅಲ್ಲ ಸರ್, ಬಟ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ 5 ಯಾವಾಗಲೂ ಹೋದ್ರೆ ಪ್ರೈಮ್ ನಂಬರ್ ಆಗಿರಲ್ಲ ಸರ್, ಎಕ್ಸೆಪ್ಟ್ 5 ones are 5. Then if we go up to any time, it will not be a prime number.
Yeah, for any such prime numbers. Same rule is applicable for any prime numbers.
ಅಲ್ಲ ಸರ್, ಈಗ 49 is a prime number.
49 is not a prime number, it's a squaring number.
49 is not a prime number.
That's
7
it.
7 is 49 ಅಲ್ಲ. 1 7 49.
It's like that. 49 is a squaring number, a square number. Okay. See, but For other things can be learnt here for 5. I will tell you how it is like that. See, now 10 is equals to, 10 is what are the factors of 10?
2, 1,
1, 10,
2,
Factors of 10.
1, 10, 2, 5.
Product of factors of 10 is what? Product of factors of 10. What is the pair factors of 10?
1 into 10.
1 into 10. Okay,
2 into
next.
5.
Let us not take 1. 2 into 5. Right. 2 into 5. Right. This is the standard property for 10. I will tell you once. And see, now, then it is come like when 10 by 2, you will have the 5. If you take 10 by 5, you will have 2 here. Is right? Even if you take a LCM like that, 2, 5. It's like. Now, see, let us take for 100 like this. It means what? So, 2 square. Now, you can write 10 to the power of 1 is equal to 2 to the power of 1 into 5 to the power of 1. Now we can take 100, some more detail, let me write. 10 is equal to 10 to the power of 1. This is equal to 2 to the power of 1 into 5 to the power of 1. If you take as 100 is 10 to the power of 2. It means this is equal to 2 to the power of 2 into 5 to the power of 2. If you take 1000, 10 to the power of 3 is equals to 10 to the 2 cube into 5. It goes on like that. See, now when it comes to the question and 1000 divisible by 2 cube, what would be the value? Like that questions are possible. What is the value? See, 10 to the power of 2 cube means it is 5 cube. 5 cube means 125. It would happen. See that, for example, even if you take the division method is 8. 2 cube is what? 8. 8 ones are 8. 2. 8 twos are 16. 4. 8 fives are 40. This is equals to 5 cube. It's like that it will come. For example, you may get a question, so far it is not there, there may be a possibility. 1 and 8 zeros, 3, like 4, 5, 6 or 7, 8, 9. Okay. So, and divisible by 2 to the power of 9. Then what would be the result? Really, we go panic.
5 to the power 9.
It's not. Otherwise, what will happen? You need one full sheet paper.
This is properties of what, sir?
10.
10.
Like that. So what is the, therefore answer is what? 5 to the power of 9. It's like that. This is the base we take, we keep doing like this. Even if you try to do LCM, there will be very huge number, but you cannot find out. Even I will do that also. One, 3 zeros, 2, 'So complicated because I have done all these exercises. 125. Again, you will start. Again is even number only. Okay. 2 6 2 2s 2 5s. Again is an even number only. 2 3s 6 2 1s 2 2s 2 5s right. Again 2, see the 2 is 2, 5, 2 6, 2 2s, 2 5s. Right, 2 3s 6, 9s, 2 0 1 2 5. It will goes on. See how difficult. 3 4 5 6 7 8. Now it will changes. Like that it will come. See, so complicated one, highly complicated. So that way they come up with a question like this. Okay, yes, that is something. Right. So now what is uniqueness of now 11? 11, see, a 2-digit number, a 2-digit number, it's a sum of digits. Digits is added always divisible by 11. Subtracting divisible by 9. Adding divisible by 11. Adding divisible by 11. Say for example 25 plus 52, like 75 77, so is equals to 11 into x, then x is equals to 7, like that is a property. These are the areas questions are designed. Subtraction of digits from the 2-digit number divisible by 9, addition divisible by 11. It's take any number of your choice like that. Say for example 72 plus 27 and 99, and see that 11 into x, so x equals to 9, x value is 9. See, subtracting it's a digit from 2-digit number always divisible by 9, and adding that digits is divisible by 11. It can be registered in our mind. Okay. Yes. Next. What is the next one? 11. Let us talk about 11 now. Another property of 11. So another property of 11 is that. So let us talk about 1 square. What is a 1 square? 1. 11 square? 121, we know. 111 square, we find very difficult. 1 2 3 2 1. It means what is the understanding here? Reversing the digits. Forward order, backward order, like a Vikatakavi. The word Vikatakavi, either you read from the beginning or from the last, remains same, like that. And now there are 4 ones are here. 1 2 3 4 3 2 1.
So in English, what we call that, sir? If we read
forward order, backward order.
There is one word.
So like that, like you can take 1 2 3 4 5 4 3 2 1, just like that. 6, if we take 6 ones, 1, it means 1 2 3 4 5 6 5 4 3 2 1, it will come like this. So this is the thing. But I think 2 years before a question was asked related to this. A question was asked related to this. I will come up with that question. I think 23 or 24. I do not know, I do not remember exactly. So these are the very properties of 11. So like squaring number. See, the question was asked in such a way, in a 9-digit number, in a 9-digit number, all are ones, in a 9-digit number, all are ones multiplied by itself, what would be the resultant number? What would be the resultant number? It's like that. Maybe one word here and there may be like different, but this is the concept. 9-digit number. How do you write 9-digit number? 9-digit number 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-digit number. All we should how to crack it. This is the cracking point. 9-digit number. We don't know. You write like this. All are ones. Multiplied by itself. Again, see, instead what we have to do, multiplied by always put square. If you try to do this, what will happen? Nobody has done it. So, squaring of number, yes. When it comes like that, you have to find the logic. Even you did not attend the class also, no problem. For example, 11 square, 121, 2 ones are there. 111 square, 1, 2, 3, 2, 1. Like this, 1, 2, 3, 4, 3, 2, 1. See, like that. When 9 is there, what will happen? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 7, 6, 5, 4, 3, 2, 1. See, now I remember what multiplied square. What would be the sum of? Now it is correct. What would be the sum of the resultant number? What would be the sum of the digits? Sum of the digits of the resultant number. Sum of the digits of the resultant number. It means, now we have done till here now. Okay, this is a very huge one. We cannot do that. But now we can say what is the sum of the digits? 1 plus 2 plus 1, 4. What is the sum of the digits here? 1 plus 2, 3, 6, 8, 9. What is the sum of the digits? 6, 10, 13, 15, 16. It means squaring of numbers. 2 square. This is 3 square. This is 4 square. Then what is here? 9 square. 81 is the. It was a question in 23 or 24.
So then again we should add 8 plus 1 then.
Yes.
8 plus 1, 9 is that?
Yes, you put up the total, it will come. 81 it will come. 1 plus 2 plus 3 plus, if you do like this, you will get 81.
Matte 8 plus 1 and add
No. Resultant number. Sum of the digits. Not necessary.
The answer is only 1, 2, 3, 4, 5, 6, 7.
Yes.
That sum is the 81.
Sum is 81. We can try for small 2, 3 items. Then you can arrive to the larger number. Same question. There was a question 23 or 25. I didn't remember exactly. 2.5 marks. The 9 digits, 9 square is 81. Because if you write for 2, 3, even if you forget also, nothing will happen. But we will teach our concepts. This is a problem issue. Next come to 101. See that. What is 11 square? 121. 101 whole square, 10201. Now, what is the logic you see here?
One zero zero one.
0 is surrounded by 2 ones, isn't it? 0 is inserted between the digits. Now, 0 is inserted between all the digits. See that? 121. Okay? Yes. 1001 whole square. 1 2 zeros, 2 2 zeros, 1. It's like that. 1 3 zeros, 2 3 zeros, 1. It means 1 1 like that. This is a concept. This 101 whole square. Okay? Yes, this is the thing. Next come to 99. Uniqueness of 99. 9 is over now. Let us talk about 99. For 99. Talk of 99. So, number 1. So, a 3-digit number. And for 9 we have spoke about 2-digit number. For we spoke about 2-digit number. And here we talk about 3-digit number. Number reversing the digits. Reversing the digits. Reversing the digits and subtracting. The result is always whenever the word always comes, that is a property, always divisible by 99. Examples let us take. 321 minus 123 is equals to 99 into x value. What is the value of x? Then x equals what? Now what we did in the previous session for 2-digit digits, subtract sum of the digits, difference digits. Here difference between first and last digits. Difference between last and first digit. 3 minus 1. 3 minus 1 is what? 2. 3 minus 1 is 2. So x value is 2. X value is 2. Even you can check also 321 minus 123, 8, 9, 198. So 1. For example, if you take some other number, like another examples you can take, like 635. 635 minus 536 is equal to 99 into 6 minus 5, 1. Like it's a 1. It's a x. So x value is 1. It means so 99 is the difference. It's like that. Here 6 minus 5 is equals to 1, like that. It's like that. Okay, yes sir. For any 3-digit number you can do 2-digit numbers and 3-digit numbers, but this is concept is not for 4 and 5-digit numbers like that, only for 2 and 3. Yes, next. For example, time either?
ಹಾಂ
Right. We'll continue tomorrow then.